Welcome back, everyone. We're up to lesson 6 now. There are no new lesson notes for this lesson, so we're going to get right into the examples here. Match each sequence with its recursive definition. There is one sequence and one definition that does not have a match. Create their corresponding match. So we're going to match each sequence with its definition. There's going to be one of each that doesn't have a match. So we're going to create a match. So let's start with number 1. So in number 1, we have 3, 6, 12, and 24. So our pattern appears to be multiplying by 2 each time, because 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So this is a geometric sequence in which we're starting at 3, and then we're multiplying by 2 each time. So let's look over here, and let's look at the ones that start at 3. So this one starts at 3, but that's not it. This one says multiplying by 5. J starts at 3, but that one is adding 5. Let's look at M. M is starting at 3 and is multiplying by 2 each time. So I'm going to kind of color code this by highlighting. So number 1 is going to go with M. So number 1 is going to go with M. Let's see. Number 2, 18, 36, 72, and 144. This also looks like a doubling situation because 18 times 2 is 36. 36 times 2 is 72. And 72 times 2 is 144. So this is, once again, a geometric sequence starting at 18 in which we're doubling each time. So let's look for ones that start at 18. So G starts at 18, but that one we're multiplying by half, so that's not going to work. K, that one starts at 18, but we're subtracting 5 here, so that's not going to work. L starts at 18, and what do you know? We're multiplying by 2. So number 2 is going to match with L. So number 2 is going to match with L. How about number 3? 3, 8, 13, and 18. So this one, we're not multiplying. This one, it looks like we're adding 5 each time, right? Because 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. So this one is an arithmetic sequence, but we're adding 5 each time. So it's an arithmetic sequence starting at 3 in which we're adding 5 each time. So again, let's look at the ones that are starting at 3 and see which one has an adding of 5. So H starts at 3, but we're multiplying by 5 each time. And J starts at 3, and we are adding 5 each time. So number 3, and I'm using a different color highlighter here. Number 3 is going to go with J. All right, let's continue. Number 4, 18, 13, 8, and 3. So this looks like a subtracting 5 situation. 18 minus 5 is 13. 13 minus 5 is 8. 8 minus 5 is 3. So on and so forth. So this is an arithmetic sequence in which we're starting at 18 and subtracting 5 each time. So let's see which ones do that. G is not going to work because that starts at 18, but we're multiplying by a half each time. K is not going to work. We're starting at 18 and k of n minus 1 minus 5. So number 4 is going to go with k. So number 4 is going to go with k. Okay. Number 5. Number 5, let's look at that. So 18, 9, 4.5, and 2.25. This looks like we're halving, because half of 18 is 9, half of 9 is 4.5, half is 4.5, half of 4.5 is 2.25. So this is a geometric sequence in which we're starting at 18 and we're multiplying by a half each time. Let's see, the only one left that starts at 18 with G, does G work? G starts at 18 and multiplies by a half each time. So number 5 goes with G. And that means number 6 is the sequence that doesn't have a match. And H is the recursive definition that doesn't have a match. So let's start with number 6. So 18, 20, 22, and 24. Okay. And let's look at what type of sequence this is. So we have to create a definition here. So 18, 20, 22, 24, that looks like we're adding 2 each time. So this is an arithmetic sequence starting at 18 in which we're adding 2 each time. So when I write that, I'm going to use f. It's going to be f of 0. Now notice here, and all the ones here, they started with term 1. But you could also start with term 0. Remember, I talked about in the very first lesson that very often we'll start with term 0 when we're talking about the term number of a sequence. But sometimes they'll start at term 1, and that's what they did here. So f of 0 is going to be 18, and then f of n is going to be f of n minus 1. So each new term is going to be equal to the previous term plus 2. So this is the match to number 6. Okay, let's do a match for H now. So H was H of 1 equals 3, and H of n equals 5 times H of n minus 1. So this is telling me that the starting term is 3, and to get a new term, I take the previous term, and what looks like our pattern is to multiply by 5. So my starting term is 3, and now to get each new term, I'm going to multiply the previous one by 5, which is what this definition says. So 3 times 5 is going to be 15. So the second term is 15. You may need to go to a calculator now, so I'm going to use the one on my phone. To get the third term, I'm going to take 15, and I'm going to multiply that by 5, and I get 75. And we're going to do one more term since they did 4 terms each up here. So to get the fourth term, I have to take the third term, in this case 75, and multiply that by 5, and I get 375. So this right here would be the match for definition, recursive definition H. And that is it for this lesson.